So a quick explanation as to why we're finding a primitive to calculate area. So if you've got an area that you're trying to calculate, okay, and let's say it's just flat like that. So that's the function f of x, which is also the height of this, and we'll change colours. Let's say we're finding it between those 2 points. So we're trying to find that area there. Okay, so the function f of x, small f, note, is the height. And surely the area changes, the rate at which the area changes depends on this height. So for instance, let's say it wasn't a constant function now. Let's say it was something like that. So the height is changing. F of x is changing. So the rate of change of the area, okay, let's say we're now finding that area. The rate of change of that area, note the word rate, is this f of x here. So what I've just said is f of x is a rate, the rate of change of the area. Well, if we go back to what we know about derivatives, therefore, if we have area, then the rate of change of the area is dA over dx, or the derivative, which is f of x. So if f of x is the rate of change of the area, well then, and they use a capital F, then the opposite of derivative, deriving, and they denote it by a big F, is called the primitive, and that's the area. So just recapping that, we're trying to find the area under a curve. As x slides from left to right, the rate of change of the function determines the rate of change of that area. So the function f of x, whatever we're given for f of x, is a rate, the rate of change of the area. So if I go the opposite way, which is called the primitive, then to find the area, I'm calculating this capital F of x, or the primitive. So to get from a to dA dx, I derive, and to get from dA dx to a, I find the primitive. And if I've got n points, then it's called integration. So the fundamental theorem of calculus. Fundamental theorem of calculus. So you can be tested on that, your knowledge of what this means. The fundamental theorem of calculus is that as we go from A to B, and there's A and there's B, we're trying to find this area, and that is the curve f of x. So as we go from A to B, and if you think about when we were dividing rectangles, okay, it's the length by the height or vice versa. So it's f of x, the height, whatever that is, times dx, the change in x, and we changed it to a d. That equals the primitive calculated at the point B minus the primitive calculated at the point A. So why do we minus? What does that mean? Well, we're finding an area. So if I find the area at this point here at B, okay, and in the last part of this lecture I talked about why it's the primitive. If I find the area there, okay, that's all that area there. But I don't want all of that area there. I only want it between A and B. So if I change it to white and I find f of A in the rectangle, that's that area there. So the difference between the two is the bit that I want, which is this area just in the middle here. So So the next video will go on to show you how to calculate primitives and thus how to find both indefinite and definite integrals and area.